In this video, I'm going to teach you how to write the electron configuration for a transition metal and then go about looking at that electron configuration and determining the ion charge it would form. What I use to write my configurations is a color-coded periodic table with the s orbitals outlined, the d and the p, and then the f's on the bottom. We are going to do the element iron, which is number 26 on the periodic table, which means 26 protons, 26 electrons. So I need to place 26 electrons into the various sublevels, energy levels, sublevels, and orbitals. So to start, we always start with the lowest energy level, which is taking into account the Aufbau principle. So I'm going to start at the first period on the table, which represents the first energy level, which as we see only has, this is an S, and this should be an S over here. This only has, for helium, an S orbital. It's not for this whole column. The whole column here would be the P sublevel. So we will go about and start at the first energy level and fill the 1s. So we go 1s2, then we go to the second energy level, or the second row, and we fill this orbital, which is 2s, 2s2. Then we keep moving in order of the atomic numbers, and we fill the p's. This would be the second energy level, 2p's, so 2p6 we would write. Then we move on to the third energy level, 3s2, then 3p6, then 4s2, and then what we're going to do is end with this iron. So we count how many places into the D's the electrons of iron fill. 1, 2, 3, 4, 5, 6. So I will fill up through the 3d6 level. When we hit this fourth energy level and the d block or the d orbital comes in, the d orbital has a lower energy level than the 4s. It's one down. It is a 3d. This level here is 4d. This is 5d. So let me go ahead and write what we just talked about. I would write the electron configuration for iron as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. And that would be my long electron configuration for iron. Now to shorten it, I go to the nearest noble gas, or the level above iron. So I'm not going to go ahead to krypton, I'm going to the noble gas before iron, so less than 26, which is argon. And basically what I do is I'm grouping argon, and I notate it by putting it into a bracket. That all of this right here, this 1s2, 2s2, 2p6, 3s2, 3p6, represents argon in brackets. And I tack on the remainder. Now, these remaining orbitals are considered the location of the valence electrons, or the outermost electrons. And those are the VIPs of the atom. They are involved in bonding, forming ions, so they are sort of the most important. So there we go. We have our long electron configuration. We have our shortened. And now we can look more closely at what occurs when it forms an ion. In order for it to form an ion, the electrons will come off the highest energy level, notated by the coefficient. So in this case, 4 is greater than 3. So what I would predict for iron is that these two electrons can come off, and if they do, I'm left with 6 outermost electrons now in a D. So therefore that would represent the iron 2+ ion. Now, if we think about the specific orbitals within the D, we can see that there are 6 remaining. Now, I know that there's some different stability that occurs with these electrons because of the D. So if I remove one of these, I have a half-filled orbital. And I know that that is also a stable situation. So by completely removing an orbital and an energy level and coming down to just 3D, I have a stable ion. But if I remove one more in addition to those two, I'm forming a 3+. The positive indicates that there is a loss of electrons. And that's how we take a closer look at the transition elements and their configurations, as well as how they form an ion.